All right, here's how to work number 32. All right, so let's say we have, first let's plot the points they give us. Just plot all the information they give you. Again, I like my scale to be, I like, instead of just, if I went to like 1 over and 3 up, like these points are too tight and I don't want to mess with my zoom too much. So I'm going to make this 1, this 2, this 3. You notice I'm making a gap of 2. So that's called adjusting your scale. And you can, if you wanted, you can make the gap 3 if you want them to be even more spread out. So I'm going to go 1 over, 3 up. Always label your points so you know how to reference them easier. All right, that's A. And then O is just the origin. I'm almost tempted to not label it, but I'm just going to label it anyway. The O looks like a 0 anyway, and I'm not too worried about that. But this angle's vertex is at the origin. And then its other part of the angle like is at 4, 0. So here's 4. So this point X right here is at 4, 0. And I'm going to draw that angle, okay? So we got this angle, that's angle AOX or XOA. They want us to find a coordinate B, so we have to create a point B, plot it somewhere, so that BOA and AOX are, so BOA and AOX are adjacent and complementary. So here's where AOX would be. AOX, again, is A to O to X. That's this angle right here. Like it's this space. Like all that is angle AOX, right? So we want it to be complementary. What does complementary mean? Complementary means at 90 degrees. Can you see where you'd have to be to make a 90-degree angle? There's an easy answer, okay? So it's like, you could just be like, oh, well, a right angle like this, right? So you can make the point like, say, right here. So you could pick the point right here. B could be at 0, 3. Could you find another space where it would work out? And don't think too hard, okay? Like this would be complementary to it. Well, it could just as easy, couldn't it just as easily be 0, 4, or 0, 5, or even 0, 2, 0, 1? Like all those make a right angle, so that works out. All right, let's find a point C, so it's on the other side. This one's a little harder. Okay, now it's good to know that when you're looking at slopes, when you're looking at right angles also mean perpendicular. Now, if you remember from algebra, when things are perpendicular, like their slopes are opposite reciprocals. So the slope of this line is you go up 3, you go over 1. That's the slope of this line. The perpendicular slope would be -1 over 3. So you could see it that way, or you could even picture it as 1 over -3. So let me plot the -1 and then up 3. See, that puts us at a point right here. So I think, that doesn't seem to work out. If I go left 1, up 3, and I make that right, it doesn't seem to make a right angle. But if you go, sorry, I did that backwards. This is here's the y, change in y. Here's a change in x. This is y, and this is x. So it actually be, you could try 1 in your y up, and then over left 3, but it doesn't make a right angle. So instead, try to make it -1 over 3, go down 1, and over 3 like this. Which again, it might be easy for you to do visually, but here's what I want you to look at. That thing right here, if you look at, instead of the yellow plus the blue making a right angle, if you notice, the yellow plus the green makes a right angle. And if you kind of rotate your screen, you can kind of see that makes a right angle right there. So point C, one of the points could be at 3, -1. So it's always going to work out that, for number 31, it was that you just made both of them opposite. For when you want it to make it perpendicular, you got to kind of swap them and change the sign on one of them and just test your 2 points. All right, and that's how this one works. Okay.